Hey everyone, and welcome to this Genesis International College Explainer. I'm so pumped to be guiding you through today's session. We're going to go ahead and put on our hard hats to master what is arguably the most critical first phase of reinforcement work, and that is planning and preparation. Whether you're stepping onto a quiet residential lot or a massive, bustling commercial site, the skills we're covering today are quite literally the bedrock of structural integrity. So, let's jump right in, shall we? Look, before a single drop of concrete even hits the ground, what you do right here on the dirt dictates whether a structure is going to stand strong for generations or just completely fail. You're not just a worker moving steel around, you are a professional executing a meticulously planned sequence. Tying reinforcement? It actually isn't about structural strength in itself. It's about holding that exact, mathematically calculated arrangement perfectly still while the concrete hardens all around it. And to pull that off, your prep work has to be absolutely flawless. So we're going to treat this explainer like your mandatory pre-flight checklist. We'll walk through the 5 essential steps every concreter must take before installing steel: reviewing the task, managing site safety, selecting the right tools, managing your materials, and lastly, executing that pre-installation prep. All right, kicking things off with Section 1, reviewing the task, the blueprint to success. This is really all about getting your head in the game. You've got to understand exactly what the work orders and job drawings are asking you to build, because assumptions in this industry, they lead to incredibly costly mistakes. Let's decode the secret language of engineering drawings for a second. Understanding these specs isn't just about passing a Genesis assessment. It's about pure, real-world application. Take a look at that top row, for instance. Getting N12 at 200 wrong, which means N12 reinforcement bars placed exactly at 200 millimeter centers, means you're compromising the structural integrity of a real building. If your spacing is even slightly off, that concrete simply won't behave the way the structural engineer intended. And let's look a little closer at lap length. If a plan calls for a lap length of 40 times the diameter of an N12 bar, you need to measure, mark, and tie exactly 480 millimeters of overlap. That math isn't a suggestion, guys. It is a hard requirement to maintain continuous structural strength right across a joint. It's the perfect example of why you've got to clarify any confusing task requirements with your supervisor before you start cutting or tying anything. Moving right along to Section 2, Site Safety and Environment, protecting your assets. Because, let's be honest, a perfectly reinforced slab means absolutely nothing if someone gets hurt in the process. You never, ever step foot onto an active site without your PPE correctly fitted and fully checked for damage. And just as importantly, you never start a task without reviewing the Safe Work Method Statements, your WMS, and the Job Safety Analysis. Safety and planning, they go hand in hand, long before the heavy lifting even begins. So the real takeaway here is that safety is a proactive checklist. Your daily routine absolutely has to include setting up barricades and warning signs to keep unauthorized people out of the drop zone. You are handling heavy, sharp materials, so those exclusion zones, totally non-negotiable. Plus, you need to ensure you're fully compliant with all environmental legislation, meaning your site controls are actively protecting the surrounding area from any runoff or contamination. All right, on to Section 3, selecting tools and equipment, the right gear for the job. Having the right gear literally makes the difference between a smooth, efficient workday and a downright dangerous delay. Before you even think about grabbing a tool, you've got to ask yourself, okay, what type and size of reinforcement are we handling today? Are we cutting, bending, tying, lifting? Whether you're using simple manual tying tools or heavy-duty powered reinforcement benders, you must inspect them for faults and really understand their limitations. Taking 5 minutes to follow the manufacturer's pre-use checks radically reduces your risk of injury and stops equipment failure from wrecking your timeline. Okay, so you have your tools, your barricades are up, and your PPE is securely on. But that brings us to a really critical question that every site foreman is going to ask. Are your materials actually ready for the pour? Because if your steel delivery is wrong, the entire operation grinds to a screeching halt. Which brings us nicely to Section 4, managing reinforcement materials, quality control. This is all about the delivery, the storage, and the absolute quality of your materials. I really want you to burn this sequence into your memory. Follow this exact 3-step process the minute a delivery truck arrives on site. First up, verify that the quantities match your schedule perfectly. Second, confirm those bar diameters and mesh types against the engineering drawings. And third, meticulously inspect the load. You are looking for any physical damage, heavy flaking rust, or contamination like oil or thick mud. Basically, anything that would stop the wet concrete from bonding tight to that steel. Now, keep in mind the materials you're verifying aren't just the big structural pieces. Sure, you're checking the deformed bars and the mesh sheets, but you also need to make sure you have the correct tie wire, the right ligatures, and the exact types of bar chairs and spacers for the job. Once it's all verified, you've got to stage those materials safely out of the way of heavy machinery and foot traffic, storing them properly so they don't get contaminated before going into the formwork. And that brings us to our final step, Section 5. Pre-installation preparation, setting the stage. This is where theory meets reality, right out there on the formwork. Listen, there is a golden rule in concreting. You absolutely cannot lay steel in dirty or unstable formwork. Before you place even a single bar, that formwork has to be checked to ensure the lines and dimensions are dead-on accurate. It has to be swept completely clean of debris, and it must be structurally braced. Wet concrete exerts thousands of pounds of hydrostatic pressure per square meter, so your formwork has to be rock solid to handle that crushing weight. Once that formwork is totally pristine, we tackle a vital concept: concrete cover. This is the mandatory distance between the outer edge of your steel and the finished outside face of the concrete. Why does this matter? Well, if the steel is too close to the surface, water's eventually going to seep in, rust the reinforcement, and cause the concrete to crack and fail from the inside out. It's a nightmare. So to prevent this, we rely on support items. To build our defense against that structural decay, we use different supports for different scenarios. For example, a plastic bar chair raises the reinforcement to maintain bottom cover. But if you have incredibly heavy reinforcement loads, you might step up to a concrete block to resist the crushing weight. A side spacer wheel is super important for maintaining side cover in vertical forms, and a stool or spreader is what holds different layers of reinforcement apart. Nailing this exact selection ensures your steel isn't going to sag or touch the formwork during the pour. Finally, once your supports are set and the steel is laid out, you've got to lock the whole skeleton together. You'll use tie wire at all the critical locations, every major bar intersection, mesh laps, tying your stirrups to the main bars, and securing any cast-in items. Remember what we said earlier? Tying doesn't add strength to the final building. Its one and only job is to ensure this precise arrangement survives the crazy vibration, the foot traffic, and the sheer force of the concrete placement. And wow, that brings us right back full circle. By treating this planning and preparation phase with the deep respect it deserves, you establish the rigorous, uncompromising habits expected of a true industry pro. And that is exactly what we strive for here at Genesis International College, making sure you don't just learn a trade, but you master the standards that keep our buildings standing tall. So I want to leave you with this one thought. A perfect structural pour doesn't start when the cement truck backs up. It starts with perfect preparation days beforehand. Keep this 5-step checklist front of mind as you move forward in your training. The real question is, are you ready to bring these plans to life on the job site? Thank you so much for joining me for this explainer, and I really look forward to seeing the foundations you all built.
Catch you next time.